Today for geometry, we will be discussing similar three-dimensional objects and the surface area to volume ratio. So for starters, we're going to discuss what makes two three-dimensional objects similar. Well, the way how we found out if two-dimensional objects were similar was if they had the same ratios between the corresponding sides. And that is the exact same way how we find out if three-dimensional objects are similar. So here we have two rectangular prisms. We want to decide if these two objects are similar. So we're going to look at the corresponding sides. So 4 is going to correspond with 12. 3 will correspond with 9. And 2 will correspond with 6. So 4 over 12, does that equal 3 over 9? And does that equal 2 over 6? Well, all three of these reduce down to the fraction of 1/3. So these are similar, and they have a ratio of 1 to 3, or a ratio of 1/3. They have a scale factor of 1/3. Any of the way how you want to say that would be fine. So these two three-dimensional objects would be similar. Moving on to this next example, here we have two triangular prisms. And once again, we want to decide if they're similar. So we're going to look at the ratios. So here we have 5 to 5. Does that equal 5 to 5? Does that equal 5 to 5? And does that equal 7 to 7? Well, here all of these ratios simplify down to 1. So they are similar, but they're actually a special type of similar called congruent. So these two triangular prisms we would actually call congruent because they all simplify down to a ratio of 1, which means that there is no change in size. For this final one, we have two cylinders. So once again, we want to find the corresponding sides. So the radiuses will correspond. So that would be 8 to 4. Does that equal the two heights corresponding 12 to 12? Well, 8 to 4 is 2. 12 to 12 reduces down to 1, and those two are not equal to each other. So these two cylinders would not be similar. Okay, so those are our three options for whether or not our three-dimensional objects are similar. We can have similar if they all have the same ratio or the same scale factor. We can have congruent if their ratios are 1 or their scale factor is 1. And then we can have not similar when their ratios do not end up equaling each other. So now let's talk about the surface area to volume ratio. So first off, what is it? Surface area to volume ratio simply compares the surface area of an object to the volume of an object. So instead of finding the full surface area and the full volume of each object, we can actually use the surface area to volume ratio to help us find it. So if two solids are similar with a scale factor of a to b, then the surface areas have a ratio of a squared to b squared, and the volumes have a ratio of a cubed to b cubed. So if we know we have a ratio of a to b, we can then find what the surface area ratio should be and the volume ratio. So for example, we first just want to find the scale factor of the two spheres. Well, something to take note is all spheres are going to be similar to each other. There's no way a sphere can have a different type of shape. It's always going to be a sphere. Just like all circles are similar to each other, all spheres are. So this would have a scale factor of 5 to 3. So let's look at the surface area. Well, the surface area of the two spheres, if this has a scale factor of 5 to the 3, the surface area, we would have to square both of those. So 5 squared to 3 squared. Well, 5 squared is 25 and 3 squared is 9. So that would be our ratio of surface areas. Now maybe you don't quite believe that, so let's actually find the surface area of both spheres. Surface area of a sphere is 4 pi r squared. So if we find the surface area of this large sphere, it's 4 pi times 25 squared. Times 5 squared. I was already squaring the 5. So when we take 5 squared times 4, we get 25 times 4, which is 100, and we're just going to leave it as pi. So the surface area of our first sphere here is 100 pi centimeters squared. Our surface area of our second sphere, 4 pi r squared, so 4 pi times 3 squared. 3 squared is 9, times 4 is 36, so 36 pi centimeters squared. So now if we look at this ratio of 100 pi to 36 pi, first off we could divide both sides by pi. And then 36 and 100 still have some common factors in. They have a common factor of 4, so we could also divide both sides by 4, and we would be left with 25 to 9, which is the same ratio we got just by looking at the scale factors of the two radiuses. So it does work, and it will work every time, this surface area to volume ratio. So now, if we have a scale factor of 5 to 3 from our two spheres, let's find the ratio of the volumes. Well, the volumes should then be 5 cubed to 3 cubed. Well, 5 cubed is 125, and 3 cubed is 27. So that would be our ratios. Now, how this can help us. Let's say I tell you that the surface area of a pyramid is 125 inches squared. I tell you that it is similar to a pyramid with surface area of 9 inches squared. And then I tell you that the volume of the pyramid with the 125 inches squared for the surface area is 1,025 inches cubed. What is the volume of the other pyramid? Well, first off, the surface area of the pyramid is 125 to 9. So this is my surface area ratio. Well, if that was my surface area ratio, to find my volume ratio, my surface area ratio came from a squared to b squared. So to find my volume ratio, which is a cubed to b cubed, at first I need to figure out what a and b are. Well, if a squared is 125, a would be the square root of 125, which is about 11.18. If 9 is b squared, my b would be about 3. So my a to b ratio would be 11.18 to about 3. So if I want to find the volume now, I would have to cube both of those. So if I cube 11.18, I now have 1,397.54. That's 11.18 cubed. 2, if I cube my 3, 27. Well, if I know that the volume of that first pyramid is 1,025, I can set up a simple proportion. So 1,397.54 over 27. So this is the volume of my first pyramid to the volume of my second, the ratios. This should equal the actual volumes. So 1,025 over, what is that actual volume? And then we just have to solve this. So we would times 27 by the 1,025, and then we would divide by the 1,397.54. A simple solving technique which we've been using many times. So when we do that, we end up getting a volume of our other pyramid to be 19.8 inches cubed. Okay, so that's how that can actually help us solve problems. That's it for this lesson. So tomorrow in class you will be working on an assignment.